And if you're a bit quiz savvy, probably this one was very easy to get, but I'll explain the answer to you, of course, as well. So at least one variable must be flipped, and the chances of flipping the right variable are at least 1/3, and I'll explain it to you. Now let's say we have one clause, and that clause has 3 variables, and it's not satisfied. So if the overall Boolean formula has a satisfying assignment, this means that in the satisfying assignment, either this variable here, this one here, or this one here must evaluate to true. And currently they all evaluate to false. So at least one of those variables must be flipped in order to satisfy the clause. What are the chances that we're flipping the correct variable, meaning that we indeed choose the variable to flip that would also have a different value in the satisfying assignment? Well, since we select 1 out of 3 variables, those chances are at least 1/3. So they are exactly 1/3 if in a satisfying assignment you have exactly one variable that evaluates to true, or a variable that is set to false with a not. And the chances are even better if in the satisfying assignment you would have 2 or 3 variables that would need to evaluate to true. But they are always at least 1/3. We initially can expect to get about half of the variables right, and a random change will be successful, or a random change in a clause that is not satisfied will be successful with a probability of at least 1/3. And that of course also means that the probability of making a mistake, meaning that we flip a variable that we should actually not have flipped, is at most 2/3.